Hello friends, welcome back to our channel. This is Senator Boss Repairs, and today I want to explain to you everything you need to know about your multimeter. Now your multimeter is it's a very handy product when it comes to electronic repairs and electrical repairs, especially at home, at work, or even at school. If you need to repair something electrical, then the meter I will always suggest, or I will always leave a suggestion, you must get a multimeter. So without taking so much time, I want to dive deep into this meter and explain to you all the functions that you see here. Now, if you're someone which is new to electronics, the first thing I want to advise you is you must be careful, because electronic devices can shock you, and electrical devices can also give you a shock which can lead to death. So always try to get your preventive measures on so that you avoid electronic shock or electric shock. So I'm gonna start explaining to you what you see here, because all these V and all these things, they all mean something, and by the end of this video you will understand exactly what to measure. And I'm also going to test some basic electronical components that you always find on a printed circuit board. So I'm going to start with the V with the sign on it, the sine wave. This is the AC. This is to check the AC volts. So the AC volts is a unit used in measuring alternative current. So AC volts, you can use AC volt to check the power outlet there on the wall to see if you are getting power from the main power source of the house. If you don't get the AC volt when you check AC volt, then something is wrong with the plug, which you need to contact an electrician to come and check if your wiring is not correct. So that is the AC volt, and it's been measured in hertz, the frequency. Because this AC volt is alternative current, which AC means alternative current. It means the current flows to and fro. It goes in front, it can go one side and the other way around. So that is alternative current. And if you want to check, alternative current comes from the power source, that is the wall outlet, and the distributor, there where you plug in your refrigerator, your fridge, your TV, and any electrical appliance that you use. So AC will always come with this sign on top of the V, which stands for the AC, and the V stands for volts, and which is measured in hertz. So number 2 will be the voltage DC. So you can always notice the voltage DC has the one line which is straight on and the other slashed line which is not straight. So DC voltage stands for direct current. Direct current means the current only travels through one path. It doesn't travel to and fro like the AC. It only travels from right to left, and that is basically what you're gonna use if you want to repair electronic devices, in checking the DC voltages, because where you get the circuit board designated for DC voltages will always, if you have an AC and DC voltage in one circuit, you always have a bridge rectifier which breaks the AC down to DC. So AC can be converted to DC through a bridge rectifier, and DC can also be converted to AC through an inverter. So I'm going to go to the third one, which is the millivolts. Here the millivolts is both in AC and in DC, and this millivolt stands for 1000 volts. 1000 volts make a millivolt, and it's basically the same like these two. It's just the 1000 volts of each. 1000 volts AC and 1000 volts DC. This is why for appliances where you are dealing with a lot of power, and here you must really be careful when you are checking the components. When they have too much, a lot of voltage, it can lead to electric shock and death, eventually to death. So we go to the next one, which is the resistance mode. This resistance mode is done in ohms. So the ohms is to check resistance. That's why I call it resistance mode. So resistance is any force that stands in the way from its hindering current from moving from point A to point B. Remember we spoke on the DC and the AC. The AC moves from point A to B and from B to A. The DC moves only from one direction, from A to B, but resistance is any force in the way stopping the current from moving from A to B. That's why you get mostly resistance mode. You can use it to check diodes as well. but the most things we always check is resistance to get where there's a high resistance or a low resistance, because a high resistance means the inflow of current is a little bit low, and the low resistance means the inflow of current is high. So the resistance mode has three main ranges. If you can come closer, you will see with me here, there's a that's a mega ohm, sorry. It's 1 million ohms. It's 1 million ohms. And then you have the kilo ohms, which is 1000 ohms. And then you have the ohms, which is just 0 ohms. I'm just gonna go through so you can see. You can see there's M and the omega sign. I'll just quickly go. Range, you see it's on ohms now. If I'm testing ohms, if I'm testing something on ohms mode and I am testing like a 47 ohms resistor, I must use this ohms range. If I'm testing a 47k resistor, that's a 47,000 ohms resistor, then I must use this kilo ohms. And if I'm checking the mega ohms, like a 4 mega ohms resistor, I must use the mega ohms. So the mega ohms is the highest because it's 1 million ohms, and the kilo ohms is 1000 ohms. So this one is used to measure mostly high resistance. And if you don't know the resistance of a thing, it's always nice to start high, so it will show you all the, if it's basically a kilo ohms, it's gonna show you kilo ohms when it's stored in, when you are busy searching testing on mega ohms. But if you put it on ohms and you want to test like a mega ohm resistor, it won't really give you the right reading, and you must put it on mega ohms. So the next is the continuity. Continuity is just to check if the current between 2 points, that's point A and B, has no interference and it's running smoothly. Continuity is also to show you that from point A to point B there is current and everything is working fine. It just helps to show you how the components on a breadboard, on a circuit board, are interrelated or interconnected. So continuity is a great tool that we use, especially when you are troubleshooting broken wires and 40 circuit board parts. You will see that from point A to B, if there's a part in the middle which is not working nicely, there will be no continuity at the end of the day. And we also use continuity to check fuses, because fuses are electronic devices which transfer current from point A to point B. So this on my left is a bad fuse, and this is a good fuse. So when I go to start checking the components, I will show you how I test fuses, how I test transistors, how I test diodes, resistors, and I will show you all of them just in a second. So after continuity mode, we go next to the diode mode. So here you can see the diode mode is the first one. If you want to go to the capacitance mode with this multimeter, you must hit the yellow button, then it will take you to nanofarads. Okay, so I'm still at the diode mode. The capacitance mode is the next. So the diode mode is used to test diodes. What are diodes? Diodes are electronic devices or electronic components which allow current to flow only in one side. Diodes are used in AC and DC circuits the same, and they have changed electronics and consumer electronics forever, for a lifetime. So diodes are very important. Diodes are used in building microchips, because if you get chips like ICs that are integrated circuits, you have a lot of diodes that are being used to form that IC. You have transistors which also come from diode. That's why diode mode is one of the basics that you need to learn as a technician to troubleshoot stuff. So without taking so much time, I'm gonna go to the next, which is the capacitance mode. And this capacitance mode is like a bonus to most multimeters, because not all multimeters have capacitance mode. Capacitance mode is used to test capacitors. Capacitors have capacitance, and that is one way to test them, especially when you take them out of circuit. So you can use ESR methods to check capacitors on the circuit if you have a lot of things to repair and you want accurate numbers. I will advise you to get the ESR method. They're all over online, but you can also use your multimeter to check capacitors out. So this capacitance mode can show you, because if you ever take a capacitor, you will see it has two measurements on the side. It has one, the capacitance, and two, the voltage. You always find the microfarads next to it is the voltage. So while I'll be busy testing the basic electronic components, I'm gonna show you what I mean by the the microfarads on the capacitor and the voltage. So you must just stay tuned and watch this video to the end to learn how to use your multimeter to troubleshoot any home appliances that just stop working. So the next on the chart is the amperes. Now here is the amperes and the voltages, they are the same, they always go together. It's like you and your shadow. And one thing that you must understand about the amperes is the amperes that is actually the power of it's the amperes that makes the electronic component go on, not the voltage. The voltage is just it's like a pathway for the amperes to go through on the motherboard. So the amperes, you have the amps in short form, but it's amperes, and it's being calculated in hertz. So you have the AC, and then you have for the DC. So all you need to do is this talks about current, while the two V's here talk about voltage. Here is millivolts. Some other multimeters have milliamps, which are designated for more amps. And how to connect your multimeter, you don't need to bother about this step. This step is a 10 amp fuse. If you're doing something, if you're testing out a component with more than 10 amps, then you can use this one. But most of the times, we don't use this one as technicians. We use these two, so you shouldn't bother about this step one. You just need to put your black at COM always, and then your red can go to volts, resistance, and continuity mode. So this is how you understand your multimeter. Like I said, multimeters vary and they are different, but this is a Fluke 117 true RMS multimeter, and this is how you understand everything that is on the multimeter. Now for the extra bonus is you have the auto volts, and then you have the volt alert. The auto volts is you can test both in DC and in AC, depending on what you want to test. And then the volt alert is just to show you how high the amperes is there, or how high the voltage is for the multimeter to handle. So the next phase of this video, I'm going to show you how I test electronic components like resistors, diodes, transistors, and fuses with your multimeter. And this hopefully can help you fix your broken electronic gadget in your house. Thank you so much for watching, and stay tuned.